how do you create and manage production-ready Kubernetes clusters? And how do you do that in a way that enables everybody in your organization to do the same? My name is Victor, and this is Upbound. We're a company behind Crossplane. For many, production-ready Kubernetes clusters means having a control plane and node pools and networking and storage and so on and so forth. But that is only a part of the picture that we need to assemble. Having production-ready Kubernetes clusters also means that we need to have certain services in those clusters running from day one. That could be monitoring, logging, GitOps, and so on and so forth. The exact services will differ from one organization to another, but what matters in this context is that we need to assemble not only infrastructure and services outside Kubernetes, but also what is running inside. And those internal services or internal applications need to be there from the very beginning. So here's what we are going to do. We are going to assemble all the infrastructure we need for a cluster, but also all the applications that cluster should contain. And we are going to package all that as a Crossplane composition so that anybody in an organization can claim such a cluster in an easy way. And once a cluster is created, we are going to configure Helm and Kubernetes providers to connect to that newly created cluster and install and configure all the services that we need in such a cluster. So let's get going. Let's do it. Let's create a production-ready Kubernetes cluster. Let's take a look at the definition that I will use to claim a new Kubernetes cluster. But before we do that, let me tell you that all the commands, including the manifests, are in a gist, and the link to the gist is in the description. So if you want to follow along or reproduce what I'm doing, you can just use the gist, and the link is in the description. So here's an example. It's in examples directory, and it's called aws.eks.yaml, and this is a simple example of a claim that anybody should be able to define. I'm going to create something called cluster claim. I will show you what cluster claim is later. For now, think of it as a custom resource definition created specifically for my organization. To be more precise, that's composite resource definition that I created, and I will show it to you later. It has a name that's normal, it has an ID, and it has a composition selector. That is a selector that has labels that define what flavor of a cluster we want. In this case, I will be using AWS as a provider and cluster will be EKS. You could change this to Google or Azure or whichever implementations of this composition we have. And then there are a few parameters easy to understand by anybody. There is a node size. I want small nodes. I do not know what small means. Whoever created the composition will map small or medium or large to appropriate AWS sizes, at least in this case. And I want a minimum number of nodes. Now let's apply this definition before I show you how all this happens. And I will do that with kubectl --namespace a-team. This is the namespace where I will claim that composition, and I want to apply something defined in a file, examples aws eks.yaml. And my claim should be created in a second. There we go. The claim was created. And now I can see all the resources that were created from that claim by executing something like kubectl get managed and releases and objects. Let's go. There we are. Now, if I go to the top, we can see a typical things that we need in AWS. Security group, route tables, subnets, and VPCs, and internet gateway, the cluster itself, control plane, node group, roles, and role attachments. That's all standard things that I already explored in quite a few videos, and I will post the links to those videos in the description. What is important in the context of this video are those guys over here. We have some objects and we have some releases. Those are the objects of all the Kubernetes manifests that should be applied to the cluster after it is created. I will show you what all those resources are later, and the same thing is happening with the Helm charts. I'm applying 4 different releases in form of Helm charts. What matters for now is that the synced column for all those is false. That's because there is no cluster yet. The cluster was not yet created, so Crossplane cannot figure out what to do with Helm charts and Kubernetes manifests, it will have to wait until the cluster is created, and after that it will fetch the connection information to that cluster and apply all those charts and Kubernetes manifests. Now, while waiting for this cluster to be created, let's take a look at how all that happened. I have here Crossplane config and definition .k8s. Now, this is an OpenAPI schema. Where is it? Here we are. It's OpenAPI schema that defines the fields that can be used in a claim, and those fields or properties are version, node size, minimum number of nodes, and GitOps repo. I will not explore GitOps in this video, that's for one of the upcoming videos. So stay tuned, because I will show you very soon how to make your Kubernetes clusters GitOps ready. But this video is not focused on that. For now, I am exploring how to make it production ready, how to have all the third-party applications that we need to run successfully a cluster in production from day one. Next, let me show you the composition itself. That's where the real magic is. That's the implementation of the OpenAPI schema that I showed you a second ago. The implementation of that interface specific to AWS EKS is here, Crossplane config, and then composition EKS, and here we are. Now this composition is quite big. I will need to spend some time getting to the top of it, right? Here we are. Let's go. A lot of things. Now there are a lot of AWS resources that I'm creating. I'm creating a cluster, a node group, and what's next? Let's see. Some roles and so on and so forth. I will not go into details of all the AWS resources that I'm creating, because I already explored that in at least one or couple of videos, and the links to those videos is in the description. What I'm interested in is what's happening at the very bottom. So let's go and find the thing that I'm looking for. Where are you? Here we have Helm provider config, and the important thing about that config is that it is using a reference to the secret to deduce how to connect to a cluster, how to connect to a cluster where it will apply Helm charts. And that secret will be created by the EKS resource that I defined at the very top. So right now the secret doesn't exist, but it will exist later on when the cluster is created. And once that secret is created, the provider config for Helm will figure out that there is a secret, and it will use it to connect to that cluster and do whatever needs to be done. And then there are a couple of Helm charts or Helm releases that I will be applying once the Helm provider config is configured. The first one will install Crossplane so that the user of that cluster can use Crossplane in that cluster as well. There will be Prometheus, and what else? Argo CD as well, and Kubevela. And then I have another provider config, but this time for Kubernetes. So I'm doing something similar with Kubernetes provider or provider config as I did with Helm provider. And what I'm really doing is actually the same. I'm just instructing the provider config to use the secret that will be created by the EKS resource, the one that creates EKS control plane. And then I'm using that provider config, Kubernetes provider config, to apply a couple of Kubernetes manifests. Here I'm creating a namespace called production, and then what else? I'm applying a Argo CD project, and what else? I'm creating an Argo CD application, and I'm also applying some Kubevela component definitions. This is one, and then this is another, and I think that I have Kubevela traits as well. Here we are, and so on and so forth. Now, which Helm charts you need in your clusters and which Kubernetes manifests you want to apply will depend, really. It depends on your specific needs, and you're likely not going to use the same applications and same services and same configurations as I'm using, but the principles are exactly the same. So let me show you what will happen and how that works through a chart which I'm going to draw right now, and I must warn you in advance that my artistic skills are not really very good, so you might have trouble reading what I'm drawing, but hey, everybody has a bad side. On one hand, I have a management Kubernetes cluster that runs Crossplane. So this is management Kubernetes that has Crossplane running inside. And inside of that cluster, among other things, I created a manifest that contains the definition of an EKS cluster. And when Crossplane received that information, it went to AWS, right? Imagine that this is AWS. Here we are, AWS. And it instructed AWS to create a real EKS cluster. Oh, no, it's like this, EKX. And now it is creating that cluster, and it is creating a bunch of other things, but for now what matters is that it is creating an EKS cluster, and it is waiting and it is waiting until that cluster is created. Once the cluster is created, Crossplane will fetch the information about that cluster and store it as a Kubernetes secret. Once the secret is created, there is already a Helm provider, Helm, and there is already a Kubernetes provider over there. And once that secret is created, it will instruct those two providers how to consume that secret and how to connect to this EKS cluster. Once they're connected to that cluster, they will be able to apply the Helm charts and the Kubernetes manifests that we created. So this cluster will be populated with all the tools and all the services that we need. So that's a high-level overview of what is happening right now or what will happen soon. I apologize in advance for my inability to write things properly, but hey, nobody's perfect, right? Now it will take a while for AWS to create all the resources, everything that we need from infrastructure perspective, and after that Helm charts and Kubernetes manifests will be applied almost instantly. But AWS needs something around 20 minutes to 30 minutes to create the cluster itself. So I will go and have some coffee and come back here once the process is done. Okay, I'm back from having a very long coffee break, and now I can check whether everything is working. I will retrieve all the managed resources and all the releases, Helm releases, and all Kubernetes objects, and let's see what I'll get. There we are. Now I got all the AWS resources. I will not go through them because this is not the main subject of this video. As I said before, there is a link to how you can assemble all the infrastructure pieces into compositions and create claims from those compositions and so on and so forth. The link is in the description. What matters here is that I have some Kubernetes objects or Kubernetes manifests applied, and we know that that's true because they are both synchronized and ready. And I have some Helm charts also applied, and the statuses of all those is true both for synced and ready. So all my Kubernetes manifests in the newly created cluster were applied, and they will continue being managed by Crossplane from now on, and the same is true for Helm charts. So far I was querying the management Kubernetes cluster, the one where Crossplane is running. So let me switch to the newly created cluster, and I can do that by retrieving the secret that Crossplane created, and that's a secret that contains kubeconfig. And I will do that with the command something like this. I will go to the namespace Crossplane system. I will retrieve the secret A-team EKS cluster, which is the name of the claim that I created, plus EKS cluster suffix. And then I will query the data in kubeconfig and store the output in kubeconfig YAML. Now, to be on a safe side, let me quickly inspect that newly created kubeconfig. And here we are, there we are. That's the kubeconfig I can use to connect to the newly created cluster. Now this kubeconfig is special. It is renewed every few minutes, so it is a temporary kubeconfig that I will not be able to use permanently. If I would like to do that, I would need to retrieve it through AWS command or something like that. So this is for security reason, a temporary kubeconfig that I can use only for a couple of minutes. And that's a good idea because it's more secure, it is renewing periodically and so on and so forth. So let me export kubeconfig variable to point to the current directory, and then kubeconfig, no, that's a typo, config.yaml. And what should I do? Well, how can I prove it to you that this is the cluster that contains all the applications, all the services that we might need? I can do that by saying, for example, kubectl get namespaces. And there we are. We can see that there is Argo CD namespace. That's where Argo CD is running. Crossplane system. This cluster got a fresh installation of Crossplane in case the team in charge of this cluster wants to have a separate Crossplane installation. I have production namespace where I would be able to deploy my applications. Prometheus for monitoring, and Vela system with kubevela, which I will explain in more detail in one of the upcoming videos. Now, as I said before, what you want to have in that cluster depends on you. This is just a sample, just an example. You should decide which charts you need, which configurations you need, which Kubernetes manifests you need. This is just for demo purposes. And before we leave, let me show you one more time the file that we used at the very beginning, that I used at the very beginning, and that's awscks.yaml. And the reason why I'm showing you this file is just for you to understand that this is a claim of the composition, Crossplane composition, that created all this. So the end users are not exposed to all the complexities of that composition. They do not need to worry about the resources that need to be created, the charts that need to be applied, Kubernetes manifests that need to be applied, and so on and so forth. All the complexity that is not necessarily required by other users, but the end users, is hidden, and I'm exposing only the things that matter. This is a completely new cross-plane resource definition, or to be more precise, a claim of a cross-plane resource definition that is used by end users. It's easy to understand by anybody, it's easy to write by anybody, and the complexities are hidden and created and defined by SRE or operator or whomever is in charge and understands everything that needs to be understood to run Kubernetes in production. That's about it. This is Upbound. Thank you so much for watching. See you in the next video.